Shall we start? Okay. Hello everyone. My name is Reza, and I will be teaching you this semester the course of Advanced Databases, CS 551. So today I'll have a brief introduction about the course, and also then we'll go overview the relational data model, and we'll conclude with the homework. The objective of the course is learning how to design and implement an efficient and robust database system. The course assumes that you had an undergraduate database course and you're familiar with database concepts, data models, and at least relational databases. However, according to the syllabus, I will just review undergraduate materials in the first 2 weeks or 3 weeks, and we will again see some of those materials and database theory from undergraduate. So another objective of the course is becoming an expert on database tuning. Database efficiency and performance is very important, specifically in companies and corporations, when from the application point of view, from the enterprise programmers, it's very important to have a good and well-tuned database. However, we are not. The goal of the course is not teaching you how to administrate a database. It's not in that level. It's a kind of higher level. We will be involved in query optimization, indexing, and data and DBMS internals to learn and to design a better and efficient database. As I mentioned, my name is Reza Baseda. This is my email, arbaseda@sandbridgeport.edu. I don't have any office today. Professor Mahmoud assigned me an office in his close to his office. I'm not sure if that's my permanent place that I can see, but as soon as I get an office, you can come to my office and ask your questions. Online questions will be answered in the next 72 working hours. It means that Sunday and Saturday, please do not expect me to answer your questions. I got my PhD in databases from Stony Brook University. My advisor was Professor Michael Kiefer, the first author of the book that we are studying in this course, and his book is one of the main books taught in all over the world, and he's one of the famous professors in databases and one of the experts. I'm so proud that I was his student. I got my PhD from Stony Brook University in 2015, December 2015, and my PhD was about database transactions and transaction logic for planning problem. Unfortunately, the course doesn't have any TA. The coursework will be homework, set of homeworks, and 2 projects. For the projects, you have to team up a group of 2 or 3 people, and there are 2 points regarding the projects. Everyone needs to be aware of the details of the project. Every step, every query. If you write a query, and if I come over and ask you some questions about the query, how did this query, why this query is in this form, why do you put the index on this field, why do you use this materialized view, you have to be aware that why, you have to be able to answer all those questions. Moreover, not only being aware of details, everyone should contribute to the project. Okay, so it's not gonna be like one person is working and other people are just getting to learn. It's not gonna work like that. And the groups are not balanced. They grade the mark of the whole group with the graded. For the projects, for the purpose of the projects, we will use Oracle Express. In order to install Oracle, installing Oracle Express is very straightforward, specifically for Windows systems. For Linux, it has some tricks. You have to configure some scripts, but anyway, it's still easy. Well, you can look at this address. I have put all of these presentations online, and you can access this address. The first assignment you're in the class is installing Oracle Express on your systems. If you cannot install and you face problems, next week probably I'll go over it and I'll show how to install at least on the Linux systems. As I told, everyone must download and use this DBMS. And here is the grading policy. The homework will be 20% of your final mark. Project 1 will contribute 30% on your final grade. Project 2 will be 10%, and Project 2 will be implemented using Java. And we will have a midterm exam with the weight of 20%, and final exam will be 30% of your grade. Okay. So anything odd here? Yeah. Total is 110%. So why is it like that? Because I would like to help the students with 10% extra, and this is the whole purpose of the course. The goal of the course is that you learn something, and I teach you some new stuff that can be used in your future career. Okay, so it doesn't matter. For me, I will be happy if you get good grades, but be 100% sure that if you work hard and you try your best, you will get a good grade in this course. Otherwise, if you don't want to work on projects, on homeworks, and also you don't study, then I'm so sorry that I'll be sad also to give a bad grade to students. So before jumping to the course, the book that we are studying will be the Database Systems and Application-Oriented Approach. You can find the details of the book in the website and in the Canvas system. I don't know if you want to buy it or if you want to borrow it from other people. This book is taught in many universities around, like in Boston University, other universities in Massachusetts. And definitely, if you have friends, you can find a book, from some people. Okay, so why are we using databases?
To store data, to organize and store data
in an efficient way.
Okay, assume that we don't want to organize it in an efficient way. We can organize it as files, right? We can store data in the files. So why do we need to have databases?
Huge amount.
Just because of the large size of data, but you're 100% sure that with the implementation of files and with the indexes, you can also manipulate and also process large amount of data. So data is stored in the computers as bits. Okay, this is the data. No matter if the sequence of bits represents your name or your address, your birthday, they are bits stored in your computer on your disk or temporarily kept in your RAM. So assume this level of data. Is it easy to work with this type of data? In order to manipulate and store and retrieve this type of data, you need to work with assembly instructions. You need to fetch them in the register, compare them. So it's not gonna be easy if you want to work with this level of abstractions. So computer scientists are doing using abstraction. Basically, we define levels of abstractions to make it convenient to work with data. So this is the main philosophy of databases. This is the growing point. This is the first point that people are going toward databases, and database theory was developed. So in the database theory, there is a very important concept called a schema, which is description of data at some abstraction level. Okay, what the schema means that at each level of abstraction, you will have some idea about the data. Okay, suppose in a program you will have a set of strings, and all those strings are supposed to keep some values for some reason. Okay, but some of those strings together are holding a specific concept. For example, some of those strings are holding my specification. My name Reza, the last name is Seda, my address is Stony Brook, like blah blah blah. Okay, the set of all of those attributes are storing one concept. This is one level of abstraction. The lower level was a set of strings. No idea, you don't have any idea what those strings are. The upper level is you have some abstraction, you know that some of these strings are together holding concept, an entity, representing an entity called Reza Seda, and so on. Okay? All of those strings, specifically by themselves, are again a level of abstractions. You call your program strings, you access them as a string, okay? But in the computer, in the register, they are arrays of bytes or characters, and they are manipulated by the compiler, by the program that you are writing, and you don't know how those are manipulated. So for example, for the concatenation, you are not supposed to know how string concatenation is happening in Java, but in the lower schema in the system, system is facing with this problem. Okay, database theory basically considers three schemas. One is physical schema, the other one is conceptual schema, and the last one is external schema. Okay, what are those schemas? So, physical schema is how the data is stored in databases on the disk, how they are loaded, how the cache management, and also all of the properties that the DBMS is facing. Okay. Oh, I have a quick question. Have you ever faced with this level of the data? Have you ever, your experiences, you need to, have you ever worked with databases and you realize that you have to change the physical schema? Or for example, fragmentation of data? When are you usually, suppose that you install the DBMS and your information is growing and growing, okay? And then the disk is full. So this is the only time that you are facing the problem involved and engaged with this physical schema. Probably you need to add disks to this system. You need to change the configuration of the database or anything like this to make it work. Otherwise, I'm sure that nobody in your experience with databases, you haven't worked with this kind of a schema. So some of the characters are not appearing well. I have to recompile my data slides. I'll do it and I will fix it and I will post it online. Basically, early applications work at this level of explicit details. So let me tell you one example. I was working in a bank in my home country, and the bank deployed a file system in 1961 to store all the information about the customers and clients. Okay, the file system was the underlying data was a set of files with some indexes, with some mechanism to facilitate accessing the files, and everything was handled by programs. And you have to, when you write a query, all those queries they had to take care of cursors, they have to go around lists, and there were people who were experts in using those kinds of files, not even for COBOL, they were pure files, and they were manipulating those programs mostly written in Fortran, C++, and even not C++, and those experts knew how to fix or how to change or how to extend their systems. So what's the problem with this kind of approach? The problem is that when routines and methods are hard-coded to deal with physical representation, it will be difficult to change data structures. Moreover, the application code were so complex because, for example, if you want to read a file in C++, what you are supposed to do is basically you have to keep a variable for file and then load it and then go over cursor, read the records, interpret it in different structures, and then process it in memory. So it's very complicated. Suppose that for every table, for every list of clients, customers, branches of a bank, you have to keep all of these mechanisms. It's going to be very complicated, and this complexity makes extensions of the system very difficult. Okay, then the database theory brought the idea of conceptual data level. So the objective of this data level or schema is hiding the details of the data. How? Abstractions in terms of what?
Security and the observation.
Not security, but when you want to design an information system for a bank, for example, what do you consider the first time?
Profiles.
What?
Profiles.
Profiles of clients, profiles of the staff, branches, information about the accounts, and all this information. You are not considering all these strings, parts of these informations. At the first glance, you are not going to see, okay, the clients should have name, family name, address, and blah, blah, blah. You are considering these entities. So, and these entities are basically kept in the relational model as tables. And these tables and this set of, and because of the similarity between records and this structure, the design of the system will be much, much easier. So, what is a DBMS?
Database management system.
So, what it is supposed to do?
Manage all the databases and it give you like interface.
Interface to what?
You can give the queries and everything.
Query processing. These are jobs of the DBMS. But in this conceptual, when I define these two schemas, where these DBMS is located? What? Give your ideas. You know, it doesn't matter if it's correct or incorrect. If you active in the class, it will be much fun for everyone, and it's very interesting and attractive class.
The server.
What?
Server.
Okay, the servers. What are they doing? Suppose that you have, I defined two schemas. One is conceptual model, the other one is physical schema. Okay? So where is the database?
Physically.
It's a conceptual.
Is it just physical?
No, it's conceptual. I mean, like it's.
Is it concept? Your friend is saying that it's physical down there. Say that it's
No,
conceptual.
it's like what's like in the physical layer we have all the data. I mean, like we have all the data. So to get the data from the physical layer, the conceptual layer helps, and like the DBMS is mainly in the conceptual layer. I mean, it interacts with the physical layer and gets the data.
Contracts with physical layer and contracts with conceptual.
Yeah, both. I mean, like it's
So
in between
it's something
them,
in between, right? Okay, perfect. Basically, database is DBMS is a software, right? That maps from conceptual to physical schema automatically. It solves this problem. From this point of view, it's very simple. It's doing some automations, but it is very important, and it really eases the job of the programmers and developers. So, what is the benefit? Physical schema can be changed without changing application. Okay, different versions of Oracle, different versions of Oracle SQL Server, different versions of each of the DBMSs are using different approaches and techniques to efficiently keep all of the data on the physical schema. These changes are happening, but when you install a new version of SQL Server, you are not supposed to change your program, your Java programs that are connected to the database using JDBC, because your program assumes that the DBMS provides those interfaces to the program. But this is the job of the DBMS to improve these disks, dealing with new technologies, dealing with new stuff. For example, these days you see SSD storage, okay? Before that it was disks, okay? In the disk it matters which cylinder you keep the data, okay? How to organize it. Many of the DBMS systems were supposed to manage all of this in order to improve the performance and efficiency. The concept of physical data independence is now can be defined. DBMS basically change mapping from conceptual to physical transparently. In all of the improvements of all of the changing of the versions of SQL Server, you as a Java programmer are not dealing with any of those changes. Okay, this transparently changing is called physical data independence. As your friend mentioned, the DBMS is something between is a software between applications and physical schema, disks and the storages. Okay. Basically, many of those storages are using files, and those files are managed by operating system. Okay. Many of the DBMS, small DBMS, like MySQL, they are relying on operating system to manage their files on the disk. They are not dealing with the disk operations. But famous DBMS systems like Oracle, for example, it uses its own disk spaces, cylinders and tracks, or on SSD, different approaches to manage by itself and improve the performance. Okay, so DBMS can turn around operating system. So good DBMS, expensive DBMSs are using their own file system. They are not relying on operating systems. One more reason, this can have one more reason. Do you have any guess why they are turning around operating system? For example, SQL Server, why it prefers to have its own cylinders and disk space, and it works by itself, not relying on operating system.
Operating system has many jobs to do, and queries might take some time.
You mean concurrency control-wise? Like,
So this operating system is doing its own jobs. So when the database
yes,
comes to
this
the
is
system some time.
yeah, exactly. This was the performance reason. We mentioned that they are turning around to skip those latencies because of the operating system. Because when they want to read some file, they have to ask the operating system. The operating system can have its own scheduling and mechanisms. Okay, this was one of the reasons. There is another reason for this type of turning the database, data operating system. Any guess?
They can do the job in their own way, with their own signature.
For why? Yes, you are getting close.
It can be for like they can have better algorithm for arranging and storing data.
The performance, we mentioned that the performance is one of the reasons. Okay, either skipping the override of the operating system or using their own algorithms, or their own indexes. What
So
else?
failure in operating system should not affect the failure in database to lose the data or security of database.
At the end of the day, the database will be run on the operating system, right? If the operating system fails or the operating system gets the control of the DBMS gets the control of the CPU back and it fails, potentially, the operating system, DBMS will have some plan for crash management, okay? They are promising you to keep your data safe, okay? But there is another reason for this. Any idea? For the security reason. You mentioned that they are doing their own encryption, they are doing their own management. Why? Because they don't want their files to be visible for other people. Because even if they are encrypting the files, if the files are visible and separated each by each, then someone can go to the file and read and somehow decrypt it. Okay, so they keep their cylinders, tracks, and everything separated, and they are doing all of their own management, and they don't rely on operating system for the security reasons. For many systems, it is like this, and specifically in banks or in commercial systems, we will see these types of features. So this is why you shouldn't have any assumption about how the files are managed. Okay, and this is why, for example, in the banks, you shouldn't have any assumption about file system. Okay, many times if your disk crashes, then you cannot use regular recovery programs to get back your files. Have you ever used recovery programs to get back files on Linux?
Yes.
How many of you have used this property, this type of program? So, how does it work usually? Was it on Windows or Linux?
Windows.
Okay, this is my experience. Once I was using Linux, but I mounted this drive from Windows, and I secretly deleted the whole files of a directory, and it was very important for me. So it was all of the pictures that I had in the United States of America, and all the memories, and it took me 4 or 5 days to recover all of those files. Even after all of those recovery, many of the files could not be seen. But it had 2 stages. The first stage was recovering the files. The recovery program was going to this disk and reading the parts that the files are mapped. There is in NTFS also there is a table to keep the information about the records and sectors and all of those stuff. It recovered all of them first, then the files and folders. The files are looking like names in very long integers or float or strings. And then after that, you have to recover the tables somehow at keeping those names, okay? In NTFS, it was very time consuming for me that recovering all of those tables, and I had to write several scripts to recover the tables and also cover the foldering because I had my pictures in different folders and all of the folders had name, and fixing all of those problems, but somehow at the end of the day I managed to get my files back. But if I deleted the database, if it was a database system, first of all, it will be accessible for me and I could delete it. Okay, it's not good. You know, the whole file should not be accessible for the users of the operating system. Second of all, if the file gets removed, you know, or crashes, then usual programs going to the file tables and NTFS tables and records are not working for many of the DBMS systems. Okay, so DBMS also has several jobs in addition to what we mentioned. First of all, it allows data definition. You can define, you can implement the design of the database you have. What else? Any guess? Tasks of the database. Many of you work with database systems. I'm 100%.
Process queries.
Exactly. Process queries, again, manage data storage, efficient querying data. More reasons. What do you mean manage data storage? What do you mean by manage data storage? But by the way, how many of you had a course about file structures or retrieving information in your undergraduate? How many of you have studied B cluster indexes, B tree indexes, and all of those? Okay, one. Okay, good. Just in the parentheses, the second project would be implementation of a type of index system. So just warm up your hands-on job. So another important thing is allowing concurrency. Many of the database systems are not single interface program. Okay, database. How many of you have have worked with SQL Server or Oracle professionally? Okay. So how is it working?
Sorry?
When you install SQL Server, what happens in your Windows, for example?
It slows down a little bit for a start.
Yeah, it slows down. Why? Because there is a program running down there. There is a small icon showing it.
Start and stop.
Start and stop. Exactly. And that start and stop starts what?
Starting of the databases.
DBMS system. Okay. And when this system database starts, what happens? You don't see anything, but it runs
It runs background.
In the background.
in the background to do what? To respond to the queries.
Yeah.
Okay, and the data definition part and also the development part is a separate program. Okay.
It runs side by side, right?
Yes, it's running side by side. You can. You need to start the DBMS by itself. DBMS, the whole in DBMS is that start and stop icon. The rest is equipments. One of those equipments is for data definition. You run it, you connect to the database, you change the tables, you write queries, you save store procedures, okay? But the database is that small things running over there. And that small thing, for example, when you are installing Oracle Express, it asks you for port number that it wants to listen to database queries, because it assumes that from some ports from the network, it receives some database queries and it is supposed to answer them, okay? So if something is happening like that, it means that you have to support concurrency, okay? because many concurrent threads outside of your system is simultaneously requesting to access your data, okay? And all of these things are happening. Do you have any famous scenario, simple scenario requirement of concurrency control?
ATM transaction.
What again? Louder.
Cash ATM transaction.
Exactly. This is a simple concurrency control requirement example that you learned in your operating system course in undergraduate or your databases. Okay? You are if two different threads are accessing different accounts to transfer money, each of the transactions should be run and executed different in different situations and different in mutual exclusion. Okay. Another reason, another job of DBMS. Come on.
Modify data.
Modifying data.
It allows the disk space properly, so that manage.
And this is fine. Data storage. Yeah, this is again the job of DBMS. Modifying and manipulation of the data. What else?
Security. Providing security to the data.
Security. Yes. And the last one is crash recovery. It promises, guarantees that your information will not be lost. Okay. And for this purpose, it has to have some mechanisms for this. Do you know anything about crash recovery? How do they crashes? How do they recover data from the crashes?
They maintain dumps.
What?
Temporary dumps.
Temporary dumps and logs,
Logs.
and they track how they change it. If in the middle of a transaction you have power outage, then this next time that the EMS is coming up, it checks if there was an incomplete job. Either it completed that job or roll back whatever it did to make everything safe. And otherwise, what will happen? Okay, you transfer money from your friend to your account. Okay, at the middle you have power outage. Okay, bank is taking some money from your friend's account, but you don't get anything. So it's not acceptable, right? So this is called crash recovery. These are DBMS jobs basically. And we are expecting these jobs from the DBMS systems. So, in the relational model, there is another schema called external schema. So, what's the difference between external schema and conceptual schema? Conceptual schema is keeping data in terms of tables. Okay, table for a student, table for a course, a table for classes, and for a table for class student. Each student can take several classes. What's the difference between these two? What do we call as external data level?
Communication between the tables.
You're getting very close. Exactly.
Relation between the tables.
Relation between tables. For example, you have a relation of a student, table of a student. You have a table of courses, and there is a relation between them. Course student. The course student keeps the student name and also course name, course number, and the grade. Okay. So it keeps this relationship, and for the external programs, it provides different views.
Yeah.
Okay, for example, keeping a joint relationship between those tables and providing a joint view for some program that computes or checks the prerequisites of courses for the students. Another application of this schema was very good and direct point. Another foreign key is a type of keeping the relationship between and creating views.
Sorting.
for data analysis.
Very, very close. Exactly. For data analysis to compute aggregates, for example, you have, for each student, you have several grades, okay? For those grades, you need to compute the average. The average is not a solid data stored in the database. This is an aggregation computed every time. From the external schema, you have that average. For example, in some forms or in some types of reports, you have that average shown, okay? But inside of the database, the average is computed by the database system DBMS as an aggregate function. So the first difference between external schema is that external schema specifies view of the data in terms of underlying conceptual level. Basically, it tailors the need of the particular category rules. So one of the applications of this tailoring is computing the aggregates. The other application is security, right? So you have tables of students, tables of professors, and tables of staff, okay? Staff can see the phone number of the students, staff can see the phone number of professors, okay? You have different applications for each of those types of users. One is for the students, they can get reports on their records, see their own profiles. Staff can see everyone's profiles. Professors can see their own profiles. That's it. Okay? This tailoring is done by external schema. In the external schema, you decide that this application should not access the phone numbers of the students because faculty is not supposed to see the phone number of the students. Okay? This is another reason and another job of the DBMS system to keep this portion of stored data secure. Basically, applications are written in terms of external schema. Some of my friends in this class also have another course job of programming. And there we write programs for enterprise and corporations. Okay, in the corporations they are dealing when you are developing a program for the corporation, and then you pass this stage that you define tables and relationship. Then you are supposed to just consider the external view. Okay, for example, you are supposed to develop a program for managing information or the portal for the faculty. Okay, then the only thing given to you is the faculty profile information and the students' grades. Okay, the external view given to you is these information, nothing more. Okay, but for the person who is developing the portal for staff, both of the information, all the information is visible. The external view given to that developer is information about the faculty, information about the students, all the information, including phone numbers, address, and everything. So the application is basically, when you're developing an application, the application is written in terms of its external schema. In the external schema, there is a concept called view, as your friend pointed. The view is computed. The view is basically usually joins or relation or keeping some useful relationship between relations and tables. These views are basically usually computed when they are accessed, but we are calling usually because we will see that it's not happening. It's not the case every time, and sometimes databases, in order to speed up, they compute the view internally, and it's called materialized view. Again, access control and different schemas. I'm going a bit faster. Again, transition from external to conceptual is done by DBMS. DBMS is the part, the component that checking the concurrency control, checking the access control and access control rules. Okay, you define DBMS users, and each user can be granted several specific rights. Again, with the definition of the external data level, we will have conceptual data independence. Basically, what conceptual data independence is similar to physical data independence. Conceptual schema can be changed without changing the application. Okay. For example, you wrote a portal for faculty in your program, and that faculty data is using faculty profile information and grade information for students. Okay. If the table for a student is changed and several fields are added, for example, these days, cell phones or like what else? These days, this is modern life. These gadgets, you know.
What was that?
Email address.
Suppose that you will purchase a Google Glass, and the glass is also a communication tool, and it has an identity. You will add this identity to the student. Everyone has a glass, of course. That this is very, very important. So if you add this information to the table of the students, that external view is not aware of that, and it's not changed. So this is called conceptual data independence. Conceptually, you change data, but external data level is not changed. Any changes may require changes in this mapping by developers as well. Developers of databases. Okay, so let's move on to the data model. What is the we read something, we studied schema, which was description of data at some level. Okay? What is model? Model is tools and languages for describing different aspects of data, different aspects in databases. For example, tools and languages to define conceptual and external schema, which is called data definition language. Tools and languages to define integrity constraints. Operations on data manipulation, transactions running, changing data, or directives that influence physical schema. Like in all the database systems, you can have instructions to change and or manage the underlying information as the database administrator. So a data model is defining data in terms of structure, operations, and constraints. Examples of data models. So the model was tools and languages to access, to define the data, to change it, to put constraints. Examples of the data. Examples of the data model.
Graphs and trees.
What?
Graphs and trees.
Graphs and trees could be a type of data model. You can define all the data in terms of graphs, for example, all of the relationships between professors. But it's not very famous. You can use it, but maybe you are the only person you are using. Yes. No, but I'm kidding. Graph processing is a top topic in Sigma conference. You know that. Social network brings the data, this type of data processing on topic, and it makes it very interesting and attractive. Relational data model. You put data, you define data in terms of relations, in terms of tables. You change them in terms of tables. Okay? Semi-structured data model. You have data, but it's not, each record is different. For example, XML files. Okay? Each XML node can be different from the others. However, you can define DTD, and you can see, I guess we'll see XML databases later on. Object-oriented databases, right? Hibernate is a type of database. You define your data in terms of objects and classes. You store it. You have persistent classes. You have temporary classes. But persistent classes are saved and they are managed by DBMS. The DBMS is called Hibernate. However, Hibernate is not very with DBMS. It maps again the data to the relational model in order to manage it efficiently. So these are examples of data models. Okay, now let's move on to relational data model. What is relational data model? Relational data model is a particular technique to structure data in terms of relationships and tables. The advantage of this data model, what is the advantage?
250 million efficient.
Efficiency is, yes, efficiency is good advantage.
Change in one.
From developer point of view,
It
how many of
avoids
you have worked with
redundancy.
persistent objects in Java? How many of you have worked with object-oriented databases? No one has stored any Java data. How many of you have worked with XML databases, large XML files? So,
XML itself is a database.
XQuery is
Yeah.
XQuery is a database, exactly. But if you work with XQuery or object-oriented databases, you realize that relational data model is very simple. Using persistent objects and classes, you have to be careful about many things. Methods, the objects you are loading, completely loaded or not, synchronized objects, and all of those criteria. Another benefit is that it has a mathematical base. It has a very strong mathematical base that can database theories to prove different features of the databases, specifically corrections or other types of features. Basically, with this mathematical base, expressions or queries can be analyzed by DBMS, and basically queries are transferred to equivalent expressions, and these equivalent expressions are optimized, and the correctness of the optimization can be proved. Okay, why? Because they have this logical foundation. So, what is a relationship? What is a relation? Assume that the relation of the students. The student in your system is defined in terms of name, last name, first name, ID number, and phone number. Okay? These are the fields. This table, these attributes, this is a tuple. Okay? The tuples become a relation. So when you are designing a database, you should make sure that should assume that tuple ordering material. Okay. Again, how many of you have worked with JDBC connected from? If you have worked with the JDBC, you know that when you submit a query, select query, and you get data back, the data is appeared in terms of a table, okay, and you will have a cursor, and you can move on the cursor, okay. So
To the next record.
exactly, you move the cursor to the records one after another, but from the database point of view, the whole thing is retrieved. There is no order until you get it to your Java programs, okay. So when you are developing a database, you should have no assumption about the tuple ordering. So basically, and in theory, there is no duplicates. However, in theory, I'm sure that all of you have worked with these database systems, and you see that duplicates are existing. The cardinality of a relationship is the number of tuples in the relationship. All tuples in a relationship have the same structure. in the relational model. Okay? This is the main difference between, for example, relational data model and semi-structured data model. In semi-structured, in an XML file, you can have different schemas. You can have different attributes.
Attributes also.
Yeah. It's a kind of tree structure.
Tree structure.
Exactly. But and each structure of the tree can have different.
Make it as a column.
Exactly. When you want to transfer, when you want to translate an XML database to a relational database, you will face this trouble that you have to go over the whole file, see all the possibility of attributes, and check all of them, and then you design or you create a table and move them, and there will appear a lot of null pointers. So another important feature is that all tuples in a relation have the same structure, and they are constructed from the same set of attributes. Again, my data has some problems here. So attributes are named usually. You can define different domains for each attribute. For example, you can limit in a database. You can limit the range of integers or anything like that. The arity of a relationship is the number of attributes the researcher should have. There is a specific value in there is a special value in databases called null, and you can for each attribute you can put this constraint that the attribute can be null or not. This is an example of a relationship. You can see the name of the student, the address, and the phone number. So, what is a relation schema? Relation schema is consisting of relation name, attribute names, and domains, and integrity constraints, like uniqueness of set of values. So, many of you have studied this uniqueness. What do you call this uniqueness of a set of attributes?
Key.
Yeah. Primary. It should be unique. Okay. Primary keys are one of the examples of this constraints. You can also add other kinds of constraints. You can define an attribute greater than 0, and you can also define default values for different attributes. So, what is a relational database? It's a finite set of relations, finite set of tables. Each relation consists of a schema and an instance. And the database schema is a set of relational schemas and constraints among those relations. A friend a few minutes ago pointed to this constraints. So what do we mean by relational schema? Many of you use at least access, right? You use access. How many of you have used access to store data? Access in terms of a table or that is.
Yeah.
So when you define tables, then you can, by drag and drop, you can define relationship between those tables. One to many, one to one, many to many. Okay, these are constraints that these constraints are part of the database schema. So then the database formally is defined in terms of set of relationships, which as a specific schema and instance, and database schema, the relationship between those relations. A database instance is a set of corresponding relation instances. Okay, that respect those constraints you have defined before. So, one question. You design a database for registration, university registration system, okay? So, is it this database instance? You just designed it.
is design. Like it's schema. When it is up and running, then it is an instance. And when it is running in the memory, it's an instance. Or else it's
When
just the
you
data.
add records, it becomes an instance. Okay. Empty tables are nothing.
Nothing.
Okay. Empty tables are not called instance of database. A database, a single database schema can have different instances. Okay, you can design the schema for course registration. You can use it in University of Bridgeport, use it in Stony Brook University, in Fairfield University or other universities. Okay, so those are instances of databases. The schema is the one that you design. Okay, so we reviewed the relational data models and databases briefly today. So the homework of your first class is installing Oracle Express. Okay? So, any questions, any ideas? So, let me ask one question. Whoever worked with object-oriented databases or object-oriented persistent classes. So what's the relationship between relational model and object-oriented databases? Any ideas?
Both of them are similar in the sense that both of them work on a relational basis. They work with the properties of a particular data object.
Yes, you're getting very close. Almost there. You mentioned
Is that inheritance?
a point when we were talking about object-oriented databases. So, you remember? Object-oriented databases, for example, Hibernate. In fact, it uses underlying relational databases, and all of those.
So,
Semi-
object oriented.
Exactly.
And I guess it uses a push technology also.
Pushing to.
Yeah.
One more question. How many of you have worked with repository management systems? Do you know repository management system?
SVM.
Some examples.
SVM.
SVN. Again, more examples. GitHub. CVS. So, what is the similarity between jobs of the repository managers, management systems, and databases?
Files in the repository management, we usually deal with the files.
More clear? We talked about the database, DBMS management, DBMS systems, and their jobs. Similarity between repository management systems. Concurrency control is one of the mechanisms they are providing, right? Several people can at the same time push and commit their code, okay? It is the task of repository management system to do all of those changes. But there is a very small difference between these two systems. What is this? Have you ever faced this problem that you have to merge your changes with your friend's changes on the repository management system? You commit, for example, you change some files, you commit, you push it and you commit it, okay? When you push it and you commit it, your friend is pushing and committing something. And he's changing what you are changing. There are two changes at the same time on this single area of the code. So at this time, it is not like databases. It's not a complete concurrency control management system. The repository management system returns to the user and asks the user to merge them. It says that, okay, I gave up, abandoned. Now you decide either your changes should be enforced, your friends' changes should be enforced, or you will go through the files and manually manage and merge those files. Okay? But in databases, you never face this question. It's not possible that you commit to transactions and database comes back to you and say, oh, I missed something. Just tell me how I should run these transactions. Okay? For the transactions, you have this assumption that always it goes through. Another similarity between repository management system and DBMS systems.
Recovery.
Exactly. Both of them promises to the users guarantees that the data will be kept safe and secure. Okay? So suppose that you commit something, and suppose that your SCN server is on your computer. Okay? You commit something. At the middle, there is power outage. Okay? When you return to the repository management system, it knows that how to fix all of those problems. Okay, similar to the DBMS systems. But in other storage systems, you are not given these kinds of facilities. Okay, if you are working with files, if there is a power outage in the middle of writing to the file, you are the only person. You are the person should resolve this problem and should answer the owners of the files. Okay, more similarities between DBMS and repository management systems. Any ideas?
Both promises advance security and cryptographic measures to protect the data.
Exactly. You put a project on GitHub and you make the project private. If tomorrow you see someone uses your code, you can go and sue the GitHub at the first glance, at the first time. Why? Because GitHub told you that, okay, this is a private, nobody is accessing it. But if someone breaks through the system and goes through your code, then it's the problem with the GitHub or repository management system. Many of all the repository management systems like SVN or CPSC are not good at these types of features, but modern repository management systems like GitHub are promising you some strong promises. So, any other similarities between these two? You're almost there. The difference between these two systems. The main difference between these two types of systems.
Accessibility options. The repositories can be accessed from any place, but the database will have to have an will have to have a granted access for the user to access the database from another remote location.
You mean the levels of access control?
Yeah.
Yes, the levels of access control in the repository management system is very simple.
Yeah.
You will give write or read access control, or someone can fork request or pull request.
But I'm also talking about accessibility to the database per se, like remote access, maybe.
Yes, if you have this access control, the access control covers all of these topics, right? You check. It's very important to you to see who is accessing your data in databases. Again, and how it accesses. But in the repository management system, it's very simple. He can write either or read or pull request and fork it. One more difference.
You can get the changes back in repository management systems, but as in the database, if you change it, like it's changed forever.
No, like databases you can also change back.
I mean, like
You can roll back transactions.
no, like I'm not like after like you have done that, and like after waiting for some time, I mean, like if there is a mechanism you can do, but like implicitly in the databases you can't do that.
In theory, with the databases also you can roll back the transactions.
I mean, if you don't have any rollback options.
If you don't have any But a very simple and obvious difference is the data structures. Databases are keeping tables, only tables. But in the repository management system, you have files. and files, and no structure on that. Okay, just streams of the strings. So this difference makes everything different. Okay, the main difference is not only the structure from the developer point of view, but also how you communicate with the repository management system. Whatever is coming to the repository management system is just streams of data. You are not supposed to, you check the structure of that data, you check the consistency and everything like that. But you are not concerned with the structure. But when you are developing the DBMS, if someone insert a student record to the database, and if the record has just name and last name, you shouldn't accept that query. You should fail that query. Why? Because a student table has a structure of ID, name, last name, and phone number. If someone sends an incomplete record, you should reject it. Okay? The main concept is that you are dealing with these structures, and you should be careful about that. So, okay, thank you very much. The class is ending at this point. So please don't forget to install Oracle Express. Next week I'll bring my Oracle Express probably either on my computer next or over